Hey, okie dokie. Hey, everyone. Okay, so we've been talking about going over and reviewing for the district benchmarks. That's in 2 weeks. And so this is the one that we were going over this week, or today, was to estimate to determine the solution. And so these are just some examples that you may see. It's not these exact questions. There won't be these exact questions, but this is examples of what they're talking about when you're solving these problems and what it would look like in a story problem. We did this in class today, and this is what I want you to start doing. Don't deviate from it, otherwise you start to get yourself confused, and we're really just starting to learn how to analyze a story problem. So let's move over to number 2. Mr. Stevens had 143 baseballs in the storeroom of his sports store. Now he puts 36 more boxes of baseballs in the storeroom. Each box contains 16 baseballs. So which of these is the best estimate of the number of baseballs Mr. Stevens now has in the storeroom? All right, so now we read it. You want to talk to your parents, or talk to your stuffed animals, or talk to your pets and let them know, tell them about the story without using those numbers, that Mr. Stevens has some baseballs that are stored in the storeroom. Now he's going to put more boxes of baseballs in the storeroom, but then each box contains so many baseballs. So we need to find out, get an estimate of how many he has. And one of the things that I'm looking up here that I forgot to add in, because we're estimating, so it's Mr. Marquez now has about, because it's not the exact, and I forgot to include the about. Alright, so the first thing that we're going to do is we're looking at Mr. Stevens as being the character. This is what he currently has in his storage room, or the storeroom. And he puts 36 more boxes of baseballs in the storeroom, and each box contains 16 baseballs. Now we said that we were going to bracket the question because we're looking at the best estimate of the number of baseballs, so we're looking at individual baseballs that he has in his storage room. So I'm going to rewrite the question, and instead of writing the word rewrite, this is what I just wanted you to remember, that you needed to rewrite your question. As a matter of fact, while we're getting in the habit, I'm just going to put rewrite, and the rewrite is, always start with the subject. The subject is Mr. Stevens. So Mr. Stevens now has, and so you see how I just now has, and here will be the blank, the fill in the blank. Now has, we're adding the word about because it's an estimate, blank baseballs in his storeroom. Now I'm letting you know, doing it this way helps make sense of what you need to solve, because it's a short story. They're giving you clues, and they're saying, hey, well, if I gave you this information, what can you get out of it? Alright, so now let's pull out our facts. You're going to bullet. Again, I know it's a lot of work, but now you're showing me the journey you took to get to your answer. You're actually reinforcing your knowledge in your brain, the journey you're taking, and now you're setting plans so that you will always remember. So I have 143 baseballs. In storeroom. I know that he put 36 more boxes in storeroom. And then I know that in each box contains 16 balls, or baseballs. So each box, I can write the word has, but I already wrote the word contains 16 baseballs. Can you right now write a numerical expression? So what can you get from the 36 boxes and 16 balls in each box? Yeah, so you have 36 times 16. And then we have to add that to what he already has in the storage room. So I have 143 and plus. Okay, so the next thing says about. So now I'm going to come down here. 143. Let me move that up a bit. What is it going to be closest to? Because look at your answer choices. They're all rounded in the hundreds, so it's going to be using it's either tens or hundreds that we're looking at. So 143. The 43 is less than 50, so is it closest to 100 or 200? If you need to make a number line, it's 100, 200, the 50 in the middle, 43 is on this side, so it's closest to the 100. The 36, is it closest to 30 or 40? Yeah, it's the 40. 16, closest to 20 or 10? It's closest to 20. Remember, our benchmark is a 5. 6 is greater than 5, so it takes us to that next one over. 6 is greater than 5, so it takes us to that next one over. And now we can multiply out. Remember what I was talking about? I said, how many zeros do I have here? There's 2. I'm putting down the 2 zeros. Now I can multiply 4 times 2, and that gives me 8. So I have 800. I'm going to close my parentheses because if I needed to go back and check my work, I know where I got my 800 from was everything inside my grouping, my parentheses. I'm going to bring down my plus sign and bring down my 100. 100 plus 800 equals 900. So how many baseballs does he have? You're right. He has about 900 baseballs. So excellent. Okay, so now I'm going to flip the page. Remember that if you need to, pause it. Flip. Now, I don't want you to get freaked out about this one. You're going to have to show a little bit of work on it, but it's okay. So this list shows the length of a day on 2 different planets. Okay, so the first planet is Neptune. That day has 16 and 1100 hours. Wow. So that's going to be about 16 hours that it has. So it's 16 hours and 11 minutes. That's a long... Well, it's a shorter day because on Earth we have 24 hours. 24 days. 24 hours. And Venus, look at this. Venus's length of day is 5,832 hours and 40 minutes. That's crazy. So now we have the statement. Which statement is best supported by this information? Which means it's not going to be the exact, but which one's going to be closest to? So we said a day on Venus. So we said it's going to be about, that's 16, because it says in 11 hours. It says it's going to be about 40 times as long as a day. So it's like, I have to try to get as close to the hours on Venus than possible. So if I come out here, I'm going to actually do my work on the top of this page. So if I have 40, and I multiply that by 16, look at what I did. I put my 0 on the outside because I know that anything multiplied by 0 is 0, and I can just multiply out. 6 times 4 is 24, carry my 2, 4 times 1 is 4, plus 2 is 6. Well, that doesn't work out. It's not even near 5,800 hours. Then it says, well, a day on Venus is about 400 times as much. Well, if I added another 0, bring that here, so it's going to be about 6,400, right? 6,400. And you're like, wait, what did you do? Well, let me show you. I'm going to scratch this out, and I'll multiply it out here. Again, remember that I said that if I multiply anything by 0, it will be 0. So instead of having all those zeros in the ones place, I'm just going to bring them down here, because that would be in the ones and hundreds, and they're going to be added up anyway. So 4 times 6 is 24. Regroup my 2. 4 times 1 is 4, plus 2 is 6. So if I added a 0, I would add a 0 here, just like I did over here. So this one is about 640 hours. This one is about 6,400 hours. Now, a day on Venus is about 50 times as long as a day on Neptune. So I'm looking at the 16. And again, we're going to go to the 50 times as much. Bring down my 0. 6 times 5 is 30. Regroup my 3. 5 times 1 is 5 plus 3 is 8. Well, that doesn't work. It's 800. 800 hours. Well, it was 500 times. Remember, I'm just going to add another 0. Bring that down. That makes it about 8,000 hours. Does that make sense? So which one of these is going to be closest to the 5,800 or the 5,832 hours and 40 minutes? Yep, it's B. You got it. So B is the correct answer. Wasn't really tough. The language is different, and so it's just kind of processing what it's asking you. Again, tell the story without the numbers so that you know what the author wants you to solve. Now let's look over here at Paula. Paula wants to buy 3 shirts and 2 belts. Okay, so Paula's going shopping. Now the shirts cost $16.89 each, and the belts cost $8.97 each. Paula has $45. Now the question is which of these amounts, so asking this, looking at these amounts, which is the best estimate of how much more money Paula needs in order to buy the shirts and the belts? Okay, so it didn't ask us how much does she have, which is going to be the best estimate, see how much she would need more. So here's what I know. She has 3 shirts. Each shirt costs $16.89. She wants to buy 2 belts. Each of those belts cost $8.97. Okay, and she has $45. Does she have enough? Okay, well, let's see. Now, if I needed to write a numerical expression for this one here, what would this be? You're right. 3 times $16.89. And this one would be what? 2 times, sorry about that, $8.97. Well, you know, we would need to add that up. So I'm going to bring this here. 3 times $16.89. Because we had to see she's going to have enough money, or how much more, about how much more will she need. Okay, well, the 3 I'm not estimating because that's a constant. It's telling me she's not going to buy about 3 shirts. It told me she's buying exactly 3 shirts. So my 3 stays the same. But my $16.89, is that closest to 10 or 20? It's closest to 20, very good. Add my 2, she's not going to buy about 2 belts. She's buying exactly 2 belts. The $8.97 is closest to $8 or $10. That's right, it's going to be $10. Now let's see. How many zeros do I have? I have 1 0. 3 times 2 equals 6. So that's about $60 that it would cost. Plus, how many zeros? It's 1. And I'm going to put that in parentheses to tell me that's where I got that answer. And you don't have